Because you have learned the Phosphagen system before from other biology courses and now exercise physiology and wing muscular power test. So I believe that you have an impression that the Phosphagen system is just for high intense exercise. However, the initiation of all exercise is supported by the Phosphagen energy system. I would like to make clear the term phosphocreatine. You can call phosphocreatine or PCR or creatine phosphate or CRP. Understanding of location of skeletal muscle creatine kinases is important. 4% are on the inner mitochondrial membrane, which is essential for creatine phosphate shuttle. And 3% are bound to myofibrillar protein of sarcomere, and the remainders are free in cytosolic solution. You need to understand creatine kinases are not only located in myofibrillar protein of sarcomere and cytosolic solution, but also on the mitochondrial membrane. This is a muscle fiber, and this is T-tubule. This is a sarcoplasmic reticulum. This is a sarcomere, actin and myosin. And this is a membrane of a muscle fiber, which is a sarcolemma. This is the sodium-potassium pump. The sodium-potassium pump system moves sodium and potassium ion against large concentration gradient. It moves 2 potassium ion into the cell where potassium levels are high and pump 3 sodium ion out of the cell and into the intracellular fluid. I believe you learned this pump from human physiology course, which is the prerequisite course of exercise physiology. ATP is hydrolyzed in the cytosol of a muscle at 3 major sites, where myosin interact with actin. When calcium ions are pumped back into the sarcoplasmic reticulum, when potassium ions are pumped back in the muscle fiber. At the site of these ATPases are the creatine kinase enzyme and creatine phosphate. Creatine kinase catalyzes the phosphorylation of ADP to make ATP and utilizing creatine phosphate and producing creatine. At this level, the net direction of the creatine reaction is toward ATP formation. Now you know creatines are product of this activity, and creatine can diffuse through pore in the outer membrane to the inner membrane of mitochondria, where it is phosphorylated by an ATP producing phosphocreatine and ADP. Mitochondrial creatine kinases catalyze this reaction. The resulting phosphocreatine can then diffuse back to the site of ATPases to rephosphorylate ADP. This process is called the phosphocreatine shuttle. Because of the phosphocreatine shuttles on the membrane of mitochondria, I can say the initial of all exercise is supported by the Phosphagen energy system. So even powerful athletes like a sprinter or a powerlifter who are usually do not train for endurance, but they had better train their mitochondrial response system, which is focusing on endurance performance.